Okay, this post was made with two questions. This is only question number one. Here's the region in question. Y equals the square root of x is this curve. X equals 3 is this vertical line. Y equals 0 is this horizontal line. And we're going to take this region and revolve it about 4 different axes of revolution. I'm assuming that this is x equals 9, although it could be y equals 9. And we're going to go through this quickly, so pause the video and take some notes. The key to these problems is being able to set up the definite integral. Revolving about the x-axis, the disk method is the easiest one to use. And the region borders on the axis of revolution, so it's the disk method, not the washer method. And we say that this is the formula times the 0, because these typical radii are perpendicular to the axis of revolution. Radius squared times the thickness of a disk. Okay, and so if you want an exact answer, it would look like this. I'll leave that to you, but mention that this is the same as x. The antiderivative of that is 1/2 x squared. Evaluated from 0 to 3. Whoops, x squared is 9/2. And 9/2 times this pi gives us 9 pi over 2. Now, if we're going to revolve around the y-axis, it's much easier to use the shell method than it is to use the disk method, although you could use the disk method. So here's our typical shell, and the height of that shell is the square root of x minus 0. That's the height. The average radius is the distance from the axis of revolution to the center of the shell, so that's x. And so there's the average radius, there's the height of the shell, multiplied by 2 pi. Again, this is x, the integrand is x to the 3/2. So the antiderivative, raise the exponent by 1, multiply by the reciprocal of the new exponent, evaluate from 0 to 3. And you can see we're going to be taking the square root of x to the 5th. That's why we have a radical in here. So there's an exact answer, which you could change to 36 pi radical 3 over 5. Okay. Now, the only thing that changes for the other two problems is the axis of revolution being moved from here over to here means that the average radius distance, an algebraic expression for this distance, which is the average radius, is the x coordinate at the right, which is, in this case, 3, minus the x coordinate at the left, which is x for a typical shell. So here's the average radius. It's 3 minus x. Instead of what we saw on the previous board, this distance was x. That was the average radius because this was the axis of revolution. So I won't go through the derivation here of this answer, but you could get common denominator here, combine that into one fraction, and get an exact answer. So real quickly, when the axis of revolution is x equals 9, the only thing that changes is the expression for the average radius. And that if this distance right here is x, then an expression for the average radius is the x coordinate at the right, which is 9, minus the x coordinate at the left, which is x. So there's your average radius, height of shell, multiplied by 2 pi. Same deal. You could combine this into one fraction and multiply by 2 pi. There you go. Hope that helped. If you have any questions, post a comment.